All right, so video number 3, we're going to talk about rotations, which is our second type of rigid motion for isometric transformations. So remember that means that our figures are congruent. So a rotation is a transformation that turns a figure about a fixed point called the center of rotation. Figures can be turned both clockwise or counterclockwise. However, if it does not note which way you are turning, then you need to make the assumption that you are going to turn counterclockwise. So counterclockwise will be our default. So the quick and easy characteristic for a rotation is that it is a turn. And remember, we're still working with congruent figures. We are not changing their size, we are just changing where they are at. So rotation is going to take that figure F, and from a point, a center of rotation, that is going to be our point, we are going to turn our F from our pre-image to create a new image, okay? And the distance from the end, every point on F to our center of rotation should be congruent to every point on F prime. All right, so we'll talk more about that in class when we look at some of the examples. When you look at a rotation, this is not a translation, and it is not a reflection. Okay, so a rotation is not a translation or a reflection. It's also not a dilation. That would be shrinking or enlarging a figure. Okay, when we think about rotation, we think about figures that have rotational symmetry. So that's when an object has a center point around where the object can be turned, and when after it is turned, the object looks the same. Okay. So if we think about this in terms of characteristics, the figure has symmetry, which is something that I think you guys are probably familiar with, but it just looks the same after it's been turned, right? Okay. So if we think about our alphabet, some letters that have rotational symmetry would include letters like X. Okay, if we turn an X 90 degrees, assuming it's a symmetrical X, if we turn it 90 degrees, the pre-image is going to look just like the post-image. Okay. So the pre-image and the the pre-image and the image, see, there I go with post-image. The pre-image and the image look the same after the rotation has occurred. Okay, so something with rotational symmetry. Our F does not have rotational symmetry. When you turn it, it does not look the same. Unless you turn it 360 degrees, and that's just not considered rotational symmetry. Okay. So the angle of rotation is how far you are turning that image so that the pre-image and the image look the same. So the measure of the angle by which a figure is rotated or turned such that the pre-image is the image. We're going to measure this in degrees because that's an angle. So if we look at our X again, that's the pre-image, and we rotate this so that it looks like an X again. This has an angle of rotation of 90 degrees. So that means if I turn an X, a symmetrical X, ooh, sorry, I don't think you can see that. But if I turn a symmetrical X 90 degrees, each time I turn it 90 degrees, it's still going to look like an X, so that the image and the pre-image will be exactly the same. Okay, we can go back to for a non-example, we can think of the letter F again. If we turn that 90 degrees, we get a sideways F, but it certainly does not have rotational symmetry. Okay, so there's no angle of rotation for that F except for 360 degrees. Okay, that's going to wrap up video number 3. We've got one more for our transformations, and that will cover our vocabulary for this unit.